Hi guys, I'm BISWARUP Mukherjee and today I will explain the basics of process synchronization and concurrency in operating system. So let's begin. We will begin with the introduction. So what is a process? A process is a program in execution. The execution of a process must progress in a sequential fashion. So if we look at the diagram, it is a process life cycle diagram. Before that, let me give you an example of what a process is just in the terms of a layman. We write our computer programs in a text file, and when we execute this program, it becomes a process which performs all the tasks mentioned in the program. I will consider the fact that details about the process life cycle will be known to all of you, but just for introduction, process lifecycle is the path of process execution as it passes through different states. So what are the states? The process is first at the start state and then it goes to the ready state. There is a queue, the ready state queue. From there, it waits. The process usually waits before going to the running state. It is called the running state queue, and then again if there is an input output call, system calls and all, then it would goes to the wait state, and then again there is a wait queue, then again it goes to the ready queue, and from running queue the process terminates at the end. Detailed explanation I am not giving in this video, so let's move forward to our topic today. So coming to the classification of process. So process types, there are two types of process, independent and cooperative process. So what is an independent process? Independent process cannot affect or be affected by other processes. They do not share any data with other processes. What is a cooperative process? When a process share variables, memory buffer, code, resources with other process, we call it cooperative process. So there has to be a sharing. The process two or more than two process will share variables, memory buffer, code and resources with each other. In this case, the execution of one process will affect the other. I will explain this more in the upcoming video slides. Let's look at the ways process can execute. There are mainly two ways: concurrent, parallel. So concurrency is the act of managing and running multiple computations at the same time, whereas parallelism is the act of running multiple computations simultaneously. It might seem confusing, but I will try to make it simpler. So here there is a difference between concurrency and parallelism, and I hope it might help in understanding the concept properly. So concurrency is the task of running and managing the multiple computations at the same time that I told, and parallelism is the task of running multiple computations simultaneously. There is a difference between at the same time and simultaneously. I will explain it in detail. Concurrency is achieved through the interleaving operation on of process on central processing unit, or in other words by context switching. So usually we switch from one process to another. That is the term context switching, which I think we all have done in process scheduling. So at a specific time, the control will switch from one process to another. The processor will send one process to wait state and will take another process into the running queue, the next process usually into the running queue because of some system calls, input output calls and so on. So this is what happens in concurrency. But in parallelism, all the processes will run simultaneously, and this, as you have guessed properly, is only possible in case of multiple CPUs, multiple processors. Concurrency can be done by using a single processing unit, while parallelism, this can't be done by a single processing unit, it needs multiple processing unit. Concurrency increases the amount of work finished at a time, While parallelism improves the throughput and computational speed of the system, of course, the process will be much faster, the execution will be much faster because all the processes are running at the same time. So concurrency deals lot of things simultaneously, but one will stop, other will start in this way. But parallelism, we will do all the processes simultaneously. Concurrency is the non-deterministic control flow graph, while parallelism is the deterministic control flow graph. Now, let us come to a diagram to understand concurrency and parallelism properly. As you can see on the right side, there is a diagram for parallelism, the execution time. At any point of time, all three processes are running. None of them, execution of all three processes, none of the execution is stopping, and all three processes are running at the same time. But in case of concurrency, of course the processes are running, but the CPU context switches from one process to another in case of priority, and then again scheduling and all those things which we have already learned. So in case of concurrency and in case of parallelism, the diagram clearly explains the difference. Now let us come to the problems in concurrency. The first problem that I'm going to mention is sharing global resources. Sharing of global resources safely is difficult. Why is it difficult? If two processes both make use of global variable and perform read and write on that variable, then the order in which various read and write are executed is critical. Now let's come to the next point, which is optimal allocation of resources. It is of course difficult for the operating system to manage the allocation of resources optimally. Locating program errors, it is of course difficult to locate a programming error because the reports are usually not reproducible. And again, locking the channel, it may be inefficient for the operating system to simply lock the channel and prevents its use by other processes. Next come to process synchronization. So what is process synchronization? Process synchronization is the task of coordinating the execution of processes in a way that no two processes can have access to the same shared data and resources. There comes a problem when we share the resources, as we have mentioned in concurrent processes. The shared variable will of course change the values in between two processes. This might lead to problem. I'm going to explain it in detail. So it is especially needed in multi-process systems when multiple processes are running together and more than one process try to gain access to the same shared resource or data at the same time. So this can lead to the inconsistency of shared data. So the change made by one process not necessarily gets reflected when other process accessed the same shared data. To avoid this type of inconsistency of data, the processes need to be synchronized with each other. Now, I will explain why do we need process synchronization with a basic example. As you can see in the given figure, there are two processes, P1 and P2, running on the same system concurrently. I will consider an operating system with a single processor. So the concurrency concept comes here. We have a global variable named shared. So what does this shared do? This shared will be shared by two processes P1 and P2. P1 and P2 both can use this shared variable. So let us first the execution begin with process 1. So shared is shared with two processes. X is increased by 1 and is changed to 6. So 5 plus 1 is 6. X and Y both here are local variables for individual process P1 and P2. Both here are not shared with each other. Only the variable shared is shared. So if we increase X by 1, it becomes 6. And then comes the sleep condition. So the sleep instruction, what does it do? It pauses the process P1 and the processor sends the process P1 to waiting state and brings in process P2. So for 1 second, the process P1 is paused. There is a context switching that occurs here and the control goes to int y equal to shared. So here y value is 5 and then again y minus minus we get 4. So y value is 4. Then again we get a sleep instruction. Context switching will occur again here and the process P2 will sleep for 1 second, will get paused for 1 second and then again it will go to the waiting queue, waiting state, and the control will return to the next instruction of process P1. As we all know that for process P1, the value of X is stored in process control block before process P1 went to sleep. So shared is reinitialized with the value 6 and P1 is terminated. Control goes to P2 and shared gets the value P4. Here again the control will go to P2 and the value that shared gets is 4. So the final value of shared is 4. So if we look at the explanation which I've already given, the value of X is 6 and Y is 4 after the end of process P1 and P2. The value of shared is 4 after both process terminates, considering the fact that process P1 starts execution first. In case process P2 starts the execution first, then the value of shared will be 6, as we can easily understand that. But if we think about the example logically, the value of shared gets increased and decreased by 1. So 5 plus 1 minus 1. It will be 5. It should remain constant, that is 5. But this is not what happening. We are getting the value 4 in case process P1 starts execution first and 6 in case process P2 starts execution first. So both are wrong. Logically, both are wrong. This should not happen. So this is a drawback of concurrency in case we share the variables. This I have already mentioned as a disadvantage of concurrency, and that's why we need process synchronization. So we need process synchronization in concurrent process. As we have told that in process synchronization, we try to eliminate the shared part, and thus going to the conclusion. From this video, we learnt about process, the classification of process and process execution, concurrent process and process synchronization. We also learnt why we need to use process synchronization with a simple example. Thank you very much.